Well, dear students, in the chapter of nuclei, we have learnt lot of things like mass defect, binding energy, nuclear radioactivity, isotopes, etc. In radioactivity, you have learned it is spontaneous phenomena in which heavy nuclei decay into lighter nuclei by emitting some radiations and energy. Now, nuclear fission is something different. If we go beyond activity, we get something other. Nuclear fission is the process in which a heavy nucleus like uranium-235, plutonium-239 captures a neutron and splits into two nuclei of comparable masses with the release of energy. Then we say nuclear fission has taken place. So in fact, a little history is required. I will write the definition of nuclear fission here. But topic is important for the sake of knowledge and for the sake of your exam preparation. Every exam preparation like class 12 examination and competitive examination also. So in 1939, Otto Hahn and Strassman, two German scientists, found that when isotope of uranium (92 U-235). Actually, uranium is found in nature in isotopes, uranium-235 and 238, in the ratio 1:145. I will discuss. When isotope of uranium U-235 captures a neutron, then it turns first into uranium-236, which is highly unstable and is broken or split, you can say, is broken into two nuclei of comparable masses. With the emission of two or three neutrons I'm telling this thing for sake of history of the topic, how it came before people. So first of all, Otto Hahn and Strassmann, two German scientists, noticed this phenomena when uranium-235 capture neutron. It splits into two nuclei of comparative masses with the emission of 2 or 3 neutron. Again, two physicists later, two physicists or two scientists, I should say. One is Meitner, lady scientist, and fission, named this phenomena as nuclear fission. Otto Hahn and Strassmann only noticed this event, and Meitner and Frisch. It's very like this. Frisch named this phenomena as nuclear fission. So now we can write this equation as there are many corresponding reactions. Directly it is not there. What I am writing, the typical reaction of fission of uranium-235 is written as 0 and 1. 0 and 1 is neutron. Atomic number of neutron is 0, mass number 1. It captures 92 uranium-235. It converts into 92 uranium-236. New isotope of uranium. I have told you isotopes are the atoms of same element having different mass number. Please don't get confused what is isotope and what is isobar. Isotopes are the atoms of same element having different mass number. This was discovered when masses of iron were measured by mass spectrometer. Then it is split into 92 uranium-236 is split into 56 barium-141. Please try to learn. Students not feel difficult to learn. Very simple. Plus 36 krypton 941 plus 36 krypton 92. Yes. Plus 3 0 and 1 plus energy. We write Q as energy. This is one, actually before this other reaction took place in which some radioactive isotopes are produced. Those radioisotopes after beta emission and energy emission convert into stable nuclei like barium 141, krypton 92. I have written here 3 neutron. It may produce 2 neutron also on an average. We find that 2.5 neutron are produced on an average because sometimes 3 neutrons, sometimes 2 neutrons. So this is the nuclear reaction. So what is nuclear fission? Nuclear fission is the nuclear reaction in which heavy nucleus like uranium-235 we can define here nuclear fission. So nuclear fission is a nuclear reaction. Nuclear reaction in which a heavy nucleus, like uranium-235 splits into 2 nuclei of comparable masses. With the emission of 2 or 3 neutrons and energy. Not necessary to learn, but there is a curiosity in the brain of every child, every person, how to define nuclear fission. So it is totally nuclear phenomena. It is a nuclear reaction. It is not radioactivity, neither artificial nor natural radioactivity. Natural radioactivity is that in which heavy nuclei split a little lighter nuclei by emitting alpha, beta, gamma radiation. Artificial radioactivity is that in which we induce radioactivity in non-radioactive nuclei by bombarding some particle. Like in one experiment, neutron was discovered, beryllium was discovered. Beryllium was bombarded with L particle, and later beryllium was emitting neutrons, but it is called like that. So try to have a critical difference, है ना? So nuclear fission is the nuclear reaction in which heavy nuclei like uranium-235. There are other nucleus also which can be fissioned. Uranium-238 isotope, the ratio of uranium-238 abundance of uranium-238 92 uranium-38 ratio uranium-92-235 equal to 145 ratio 1. They occur together in the same compound. They are not separated. It is difficult to separate them. That is the problem. But in one nuclear reaction, when high energy neutron, like energy having more than 1 million electron volt, is captured by uranium-238, it is converted to other radioactive, other heavy nucleus which can be fissioned easily. I will be telling you later on. So nuclear fission produce energy, and that energy produced here, the energy produced in nuclear fission reaction, the energy produced in the nuclear fission is obtained in the form of kinetic energy. Kinetic energy of fission products or fragments. Actually, I want to tell in simple language, fragments in the form of kinetic energy. When these fragments move through a material, the kinetic energy of fragments is converted into heat. This energy converted to heat, and we can use this heat energy for useful purpose like in nuclear reactor, nuclear bomb, which is also called as atomic bomb, and nuclear reactor. Nuclear reactor is a device where we converts nuclear energy into useful electrical energy. Reactors are used also for other purposes also. So nuclear bomb and reactor are based on nuclear fission reaction. I will discuss later on. Now, how to calculate the energy released? It is simple here. We can calculate the energy released using bioenergy curve. From binding energy curve, we know that binding energy of uranium-236 is 7.6 MeV, while that of fragments 56 Ba, 141 and 36 krypton 92 is nearly 8.6 7.6 8.5 sorry 8.5 MeV. And by energy, remember, is the energy liberated by the nucleus to form the nucleus. So 0.95 MeV is the increase in binding energy per nucleon of fragments of fission. U36 has 236 neutron or nucleon. So I told you that bind energy is the energy released. So in the formation of nuclei of barium and krypton, nearly point difference is this 8.5 minus 7.6, nearly 0.9 MeV energy per nucleon more is released. So 0.9 MeV of energy so total energy released by fission of a nucleus of uranium-235 6 is equal to 0.9 into 236, which is equal to 9 6 54, 5 9 3 27 or 5 27 5 32, and 9 2 18 or 3 21. So nearly 200.4 MeV energy is released by the fission of one nucleus. We know MeV is not a big unit of energy. You know, 1 MeV is equal to 91.6 into 10 to the power minus 13 joule. I have proved. So it is very small, but remember it is emitted by fission of one nucleus. If you think about how many nuclei are present in 1 gram of atom and multiplied by this, if 1 gram, so 1 gram of uranium 236 or 235 equal to how many atoms? 6.023 10 to the power 23 upon 235. या 230 ले लीजिए, कोई बात नहीं. तो ये होगा. So energy released into this MeV, and hence Q is equal to 6 into 10 to the power 23, nearly 236 into 200 MeV into 1.6 10 to the power minus 13 joule, which come out to be equal to, if we calculate it in kilowatt hour, or equal to this nearly 2.8 2.28 10 to the power 4 kWh. You know what is kWh? Kilowatt hour, unit of energy, which we use to measure the electrical energy consumed commercially by us. यानी कि 22,800 units of electric power equivalent to the energy released by fission of uranium 236, which is equal to which can be obtained only from 20 tons of TNT. Right? So that 1 gram uranium produce large amount of energy. If anyhow we can convert this into useful, then it will be a very useful and very good source of energy. And we are doing this. Atomic reactors are converted into this energy released by fission. There are different problems in getting this, but it is very safe and eco-friendly source of energy. I will be discussing later on. Now, in next video, I will come to some other facts about nuclear fission, chain reaction, uncontrolled and controlled chain reaction, and nuclear reactor. Thank you. Please watch videos. Actually, I have seen that a small number of viewers are there who studied, who watched the video in which I have solved many numerical based on rate of radioactivity. Please watch those videos because those numerical are very important. Thank you.